Welcome to the session. In this session, I am going to talk about classification of batteries and some important applications of batteries. Classification of batteries. Batteries are classified based on their capacity to get electrically recharged. Some batteries they can be recharged, some they cannot be recharged. Okay, so based on their ability to get recharged, they are classified into three types. They are primary batteries, secondary batteries, and reserve batteries. First one, primary batteries. So working principle of the primary batteries is the conversion of free energy change of the active materials during electrode process into the electrical energy. So simply, in primary batteries, free energy of the chemicals used that will be converted into electrical energy. So this is the basic principle of all the batteries, of course. But here, primary batteries they are not intended for recharge. Okay, they cannot be recharged, and once the primary battery is out of charge, it will be discarded. And in primary batteries, the cell reaction is irreversible. Cell reaction is irreversible. So when we are using the battery, primary battery, the reactants or chemicals present in the battery, reactants, they are converted into products. Forward reaction occurs here. And once all the reactants are converted into products, and the primary battery is out of charge and it will be discarded. It cannot be recharged. Okay. So as long as active materials are present in the battery, it will provide power. Okay. Once it is out of charge, it will be discarded. So those batteries are called as primary batteries. And example is zinc MnO2 manganese dioxide dry cell. It is also called as zinc carbon battery also. Okay. So this is that one. This is a primary battery. It contains a positive terminal here and a negative terminal here. Then in the middle we have a carbon rod. Then the outer container is the zinc can. It is made up of zinc. Then we have a gasket here to keep the carbon rod in position, and we have electrolytic paste. Then cathodic mixture also is there. So this is a primary battery. Okay, so it cannot be recharged. Then second type of batteries are secondary batteries. They are also called as rechargeable batteries. They are also called as accumulators, and they are also called as storage cells also. Several names are there for the secondary batteries. Okay, so these are also called as galvanic batteries. Another name, galvanic batteries. Okay, so these batteries after discharge, when they are out of charge, secondary batteries, they can be restored to their fully recharged state, fully charged state by passing a direct current, electrical current, in the opposite direction to that of the discharge. Direction of current during discharge opposite to the direction, electrical current will be passed during charging state. Okay, and in these batteries, secondary batteries, cell reactions are reversible. Cell reactions are reversible. When we are using the battery, we will get power, and chemical reactions occur in the forward direction, and the reactants are converted into products. This is forward direction, we get power, and the battery is out of charge. Now it will be charged by passing electrical current in the backward direction, I mean opposite direction to that of discharge. And in this situation, the backward reaction occurs. The reactants are sorry, the products are converted back into reactants. Okay, reversible backward chemical reaction occur here. Okay, so these are also called as storage batteries, and examples are lead acid battery, nickel cadmium battery. These are examples of secondary batteries. And secondary batteries have a better cycle life. They have good capacity, and they can be used again and again. Okay, by charging and discharging. Okay. Uh, Secondary batteries are classified into two types: acid storage battery. Example for that category is lead acid battery, and alkaline storage battery. Example for that is the nickel cadmium battery. Okay, and this is a secondary battery. Actually, this is a lead acid battery. Okay, so this is one terminal. Okay, so this is another terminal. So this is positive terminal. This is secondary terminal. Okay, so actually, generally this is made up of six cells. Six cells are combined to form a battery, especially in the lead acid battery. This is an example for secondary battery or storage batteries or rechargeable batteries. So these can be used again and again by charging and discharge. And we'll move on to the third one, third type of batteries, reserve batteries. So in reserve batteries, a vital component, important component is separated from the rest of the battery, rest of the components. So a vital component is separated. So this is generally done to prevent the self-discharge and also for long-term storage. Okay, self-discharge. Some batteries, even though they are not used, if they are stored during storage itself, they will run down. They undergo self-discharge. That process is called self-discharge. Okay, and this will be prevented in the reserve batteries by separating a vital important component of the battery. Okay, this is one one advantage we get if we separate the vital component. Another advantage is that for long term storage we can store the battery for longer period. Okay, if we separate the vital component. And usually in most of the reserve batteries, vital component which is separated, that is electrolyte. Electrolyte is the vital component that is isolated from the other components. And reserve batteries are especially preferred for applications where we need high power and for shorter periods. For short period of time, if we want high power, we'll go for reserve batteries. So reserve batteries are mostly used in missiles. I mean, especially in warfare, missiles, torpedoes, war weapons, and some other weapon systems. Okay, so best example for reserve battery is lithium vanadium pentoxide battery. Okay, so this is the reserve battery. Okay, so okay, different brands we have. So this is about the classification of batteries. Next topic is applications of batteries. Batteries have wide applications. They are used in many electronic devices. Let us discuss some applications of batteries. First one, car batteries. So batteries for car or other vehicles, they need high specific power, and for large mechanical load, operating temperatures, low operating temperatures, and safety is also a concern, and environmental safety is also a concern here. Okay, so these are the requirements for car batteries. So batteries should have high specific power, they should be safe, they should not damage the environment, they must be used, or they can be used at low temperatures, and also they should bear large mechanical load. So batteries for these conditions, they are used in cars and other vehicles. So example for car battery is lead acid battery, lead acid cell. So you can see this is the in the picture. So this is a lead acid battery. This is mostly used in cars and also in transport vehicles like lorries also. Okay. Then another application is EPV, electrically powered vehicles. So nowadays there is great demand for the vehicles which run with the power. Okay, so they also need the assistance of batteries. Okay, so actually batteries in electrically powered vehicles, they are replacing the combustion engine. Okay, so they need sufficient energy. The batteries used for electrically powered vehicles, they have sufficient energy and power density. They should, at the same time, they must be safe without destroying the environment, and cost is also issue here. The batteries for EP vehicles, they should not be expensive. Okay, so this is another application of batteries. Next one, batteries are used secondary cells. Secondary cells, rechargeable batteries. They are used for portable high power applications. Portable high power appliances such as laptops, power tools, flashlights. We use torch lights, all these ones. Rechargeable batteries are used there. And for laptops, you can see in the picture. This is the battery which is used for a laptop. Okay, and this is a battery used for electrically powered vehicle. These are some applications of batteries. Next. Primary cells are preferred. Primary batteries are used especially for portable low power appliances. Portable low power applications, we use primary batteries. The applications like watches, wrist watches, meters, cameras, calculators, they run with primary batteries. Okay, and for these batteries, low power density is enough. Low power density is enough, but low self discharge rate and high energy density are desirable for these applications. Okay, and long service life is also required for these applications. Best example is lithium batteries are mostly used for these type of applications. Okay, so primary batteries which are used for portable low power applications, they should have low discharge rate, low power density, high energy density, long service life. Okay, so these are the required conditions for portable low power applications. Examples are lithium batteries. Next, another application is military applications. Military applications we use especially reserve batteries, especially reserve batteries. So military applications for warfare weapons like missiles, torpedo, they uh, need assistance of a battery. So those batteries are shown in the picture. You can see these are the missiles. They run with the batteries. This is a reserve battery. Okay, so these are reserve batteries are mainly used for military applications. Next, important applications of batteries, pacemakers. You can see in the picture the X-ray. This is an X-ray. Uh, you can see a device here which is inserted on the left side. Okay, that is the pacemaker. Okay, people suffering from heart problems. Okay, to ensure flow of blood, a pacemaker will be inserted in the body adjacent to the heart of a person. Okay, these pacemakers they run with batteries. Okay, example for such batteries is a lithium iodine battery that is used for pacemakers. And here for pacemakers, the batteries service life should be long. Long service life is required. Safety is also very important, and discharge profile is also very important. These three are very important. Why? Because again and again we cannot remove the pacemaker inserted into the body of a person. Again and again they cannot be removed and inserted. That's why. So long service life, safety, and discharge profile. So these three are very important uh, for a pacemaker. But cost is not an issue. Next application is hearing aids. Usually, batteries for hearing aids they are made with mercury, silver oxide, or zinc air batteries because of high volumetric energy density. Allows for a small battery. So battery is very small. You can see in the picture. These are the battery. This is hearing aid. Okay, and here we can insert the battery. These are the important applications of batteries. Thank you.